right now? Okay, so I just started this recording. I'm going to give a brief overview. Lecture quiz chapter 13 is due next Monday. Test is on Wednesday. Review and revise your draft 1 paper and your methods that I have handed back to you. Thank you, Amy. Okay, so now, oops, hopefully you can see my page. It's really weird. It's not showing me my page. I guess I could do this. Okay, do you see my PowerPoint?
No.
No. Okay, so let's do this. I'm not sure why it's not. Oh, there it is. Okay. That's really weird. Oh, hold on 1 second. I'm so sorry. Somehow I lost it. I had to reopen PowerPoint. All right, so now, okay. Can you see my PowerPoint?
Yes.
Okay, good. All right, so we just need to talk a little bit about graphing some more, because really your goal moving forward now when you're writing your paper is to represent your data in a meaningful way. All right, so line graphs, like you learned in are used to compare data sets over a period of time. So you can see here, a lot of you are doing time courses like this, where they're minutes, or you're doing it every 7 days or something like that, and you're using different types of treatments to see how they are affected over time. So that would be how you would use a graph like this. All right, make sure you're labeling your axes, right? So dry weight, concentration, and then make sure you put your units. So this is grams per liter, and then you can put time down here in hours or time in minutes or whatever. And then make sure you always have a legend. So so you can see here they use different colored lines with different shapes, so you could tell which line represented what category of data. Okay. This one doesn't have a good title, but make sure your titles are descriptive. So kind of like effects of essential oils on E. coli growth, or effects of differing nitrogen concentrations on porphyridium, something like that, right? And then, of course, you're going to have to put your caption. So you've got a little bit of practice with that this week. Next week, you're going to actually plot your own data, caption for your own data. And this is before you have to put it in your paper. So I'm going to give you some feedback on it so that when you put it in your paper, it's already kind of completed. All right. And then the next thing I'm going to talk about in a minute are error bars. And we'll talk about error bars in just a minute. All right, the other kind of graphs that you might consider using would be bar graphs. And this is the way the kind of graph you would use to compare categorical data. So for example, if you were comparing males versus females, or you know, different age groups or different ethnicities, something like that, you would use a bar graph. In the lab, you might also use a bar graph if you were going to see the different effects of different antibiotics, for example, on a variety of different bacteria. And some of you are doing that. So if it's not really a time course, the bar graph is the best way to do that. All right, and the same thing, you make sure you have a descriptive title. This is not a good title, right? You want to say the effects of different antibiotics on 2 different bacteria or something like that. Make sure you have labeled axes, so they have zone of inhibition here, and then they have their units in millimeters. And then on their x-axis, they have types of bacteria, and types of, well, actually this should say types of antibiotics, and then their bars represent the different types of bacteria. And then, of course, a caption and error bars. So any questions on when to use what kind of graph? Does everybody kind of have a sense with their data what kind of graph they would want to use? Anybody have a question on their particular data? Okay, well, good. So one of your assignments for next week is going to take the data sets I gave you and create a graph in Excel, caption for it. Can you plot time on a bar graph? Let's see. It depends on how you do it. So if you are not comparing something over a course of time, instead you just did the experiment 3 times on 3 different days, in that sense, yes, you could use a really seeing how growth changes over a period of time, then no, you don't want to use the bar graph. Does that make sense? Irwa, does that make sense to you? Okay. All right, so the next thing we have to discuss are error bars. We talked about standard deviation earlier in the semester. Remember that thing where we had to do the sum of the value minus the mean squared divided by n and then take the square root? So one of the reasons you calculate standard deviation, for example, is to use that information to help you show the confidence or the variance within the data that you've collected, right? So error bars help us that variation in our data, all right? So this graph here shows you a bar graph with error bars included, all right? And so basically they show you, so if you just look at the bar is telling us the mean. So remember, if you've done this, your experiment 3 times in triplicate or in 3 flasks, you're going to average those 3 numbers together and get the mean, and then you're going to plot the mean. Okay, so this green bar here represents the average data point for that particular treatment. And then the error bars tell us how the actual data was dispersed across that mean. So in this case, you can see that there was a little bit of numbers that were a little lower, a little bit higher. In this case, near the mean, whereas in this one, they ranged all over the place. Everybody see how that differs? And there are different ways to use error bars. And really, you have to, in order to understand what the error bars are telling you, you have to indicate in your caption what kind of error bars you're using. So you could use them to show something called a confidence interval, and this has to do more with statistics, and you'd have to do a t-test, and we're not going to do that this semester. You can also use them to be representative of standard deviation or standard error. We're going to just focus on standard deviation. All right, so that, and that's a descriptive type of error bar that tells us descriptive information, so we can just at a glance see kind of where that range of data falls around our mean. All right, so you can just see here's the 3 different kinds. This would be standard deviation, and typically with standard deviation, you have the bar goes under the mean just as far as it goes above the mean, so it's kind of centered right around the mean. That's not necessarily true of the other 2 always. All right. So just a reminder, oh, and here's how it might look on a line graph, all right? And you can see here they didn't choose to do it on every point. They just kind of did it on some points along the way. So just a reminder on how to calculate standard deviation if you forgot. It is earlier in the semester, right? So it is the square root. Ooh, I wonder if I have a calculator function. I'm going to have to just draw that. It's the square root. Woo! Hold on, let me erase it. That was bad. I'm just getting good at this too. Of the actual number that you collected minus the mean. Remember that, how we had that table where you had to list the numbers and then calculate the mean and then list the mean? and you're going to take that number and you're going to square it. Remember that? And then you're going to divide that by n number of total categories you have. Oh, I just erased the whole thing by accident. Right? So you're going to do x, which is the actual value, minus that number is going to be squared. You're going to take the sum of those, and I make that, remember that meant sum, and then divide by the mean, by the number of categories, and then take the square root. So go back in your notes. If you can't remember how to do that, I had you guys calculate it. Now, this is really easy to do when you get into Excel. All right, so, oops, you can't see that screen. Hold on, I'm going to share my screen with you again. Ooh. I'm getting better at this, I promise. Started. Okay. So here is an example of a data set. So maybe you had 3 samples and you measured them over time. For example, maybe you did day 1, day 2, day 3, day 4. Maybe this is treatment 1, treatment 2, treatment 3, treatment 4, however you want to do it. All right. And these 3 samples were what you did in triplicate. So remember, you're going to make sure you take the mean of all of that, right? Now, in Excel, it's really easy to calculate that mean. So if you click on this mean column, if you just type in the equal sign, so it looks like, I'll type it in down here, it looks like the equal sign, and then the word mean, and then, oops, let me see if you have it here. Let's see if I can just show you here. Okay, no, it's actually average. So if you type in the word, the equal sign, the word average, and then the columns that you want, cells that you want to include. So you select B2, B3, and B4. It will calculate the mean for you. So that's kind of nice. You don't actually have to calculate it on your own. You can let Excel do it. You do have to have all your stuff in a table, but I've already sent you everything in a table. So that's already organized pretty nicely for you. And you can use Excel. All you have to do is say standard deviation of those same columns, and it calculates it for you. So that is really cool because you don't have to do the math and make that table if you don't want to. You can just use the tables I've given you and then add these rows of mean and standard deviation to calculate it. Okay, does that make sense? And I posted in your shared folder and also in the announcement that I sent out yesterday some really good tutorials on how to use Excel to build these graphs and add in the error bar. So it goes step by step, like what button do I want to push when I actually am making the graph and I'm adding the error bars in. Okay, so I could go through it with you right now, but I think these videos are probably better and more useful because you can have them playing like maybe on your phone and your data up on your computer, and you can be doing it step by step with your actual data while you're watching the videos. Okay, so oh, I guess I didn't share that with you. Did you see that? If I change tabs, can you see the links to the videos or no? No, you don't see those?
No.
Okay, hold on. Let me see if I can share that with you. Can you see it now?
No.
You still can't? Oh. Now do you see it? Yes, there it is. Those are the links that I put in the announcement, and they're pretty good videos. They're not very long, and I really suggest you have it open and you're actually working step by step with your graphs. Okay, so that's one of your tasks for this week, is to actually graph your own data, and so we'll that in just a minute. So in your shared files for lab and in Blackboard, you'll find the Graphing 2 and Graphing 3 exercise that you have to do. The Graphing provides you with some graphs and asks you to interpret them. The Graphing 3 exercise, data sets that I gave you, and graph. Label everything, graph it, put in error bars if you can, write a caption, and turn it into me by next Monday so that you can get feedback before you put it in your actual paper. So one is just more of another practice, and then the other one is actually graph for your paper. Okay, and again, I am okay with you writing that as a building your graph as a group. I do on it. So if you do it all by yourself, don't just give the graph to your lab mates. I would rather you, you know, work together on it somehow virtually. Maybe watch the videos on your own and come up with it, and then together say, this is what I came up with, what do you guys think, and have them make comments and stuff. I know it's a little harder with being virtual. So I did send everybody a set of data. Did everybody get that data that I sent last time or on email yesterday?
Yes.
Yes.
Some of you I sent a couple days ago. Okay, that is your data. If you need more data, if you feel like, well, that's a good start, but we wanted to do this 3 different days or something like that, let me know, because we can come up with another set, or you can come up with your own second set. You can kind of fudge the numbers if you want to. That's your call. So really make your project fit that data, but as much as possible, you should make sure the data you have fits the project you wanted to do. Have you had a chance to review that data together as a team yet? You probably haven't, have you? So let's do that. Let's, I'll put you into your lab groups and you guys can pull that data up onto your computers or wherever you have it and just discuss, because if you need something else, this is the time to do it. So let me put you in some groups. Okay, let me put them in groups now. In groups now, and I think I know your groups now. So no, I'm going to custom assign. Let's see, we'll start with. All right. Jessica and Reggie. Reggie. I'm going to put Henry, Ivan, Ashley. Alexis, you're by yourself, just so you know. I'll still pop in and talk to you about. And then Elaine, Grace, and then Gretchen. Is Gretchen here? Yeah, where's Gretchen?
Dr. Bird, I found the data before, but now I forgot where it was.
I emailed it to you. And then this one will be the last. So Hannah, I'm going to make you a moderator so then you can jump in and out of groups with me.
Okay.
And just go in and just, find out if there's any needs that they have, if they understand the data. I didn't send you the data, but they can tell you what they're looking at to make sure they understand it. All right?
Okay. Sounds good.
I should have copied you on all those emails. Okay, here it comes. Ready? Go. Right, and then I have to add Hannah as a moderator. Hannah, can you hear me?
Yeah, it just said that
Okay, good. And so right next to the group name, there's like a little rectangle that has a arrow pointing to it. So just hit that one to move into that group. Do you see that?
Okay, let me see. Say that one more time.
So, you have, don't with the little people.
Oh, okay. Yep. I see
Okay,
it
and
now.
then it says group one, and then there's a thing.
Mm-hmm.
Okay.
Okay,
Excellent.
perfect.
Okay, I'll meet you in there.
Cool.
All right, so